Heating and cooling a metal building can be pretty expensive. In my case, I wanted a certain size building, but I spend a majority of my time in a rather small area inside that building. In the winter, all of the heat will rise straight up to the 13-foot peak, and it doesn't do you a whole lot of good. I wanted the option of heating and cooling a smaller space and keeping it pleasant without having to worry about the rest of the building. So I decided to build a small cabin inside of my metal building and save enough floor space outside of that where I could still do projects, still work on metal and wood and do big projects, have a reasonable amount of space, and have a lawnmower in there and not worry about tripping over it all the time, and have plenty of room to spare if I needed it, and also have a very nice conditioned space that could be cooled or heated as needed. The cabin is 14 foot by 20 foot wide. It's also about 7 foot high, minus any floor treatments or ceiling treatments. This is to give me some headroom, but also minimize the cubic feet of space I'm having to heat and cool. There's no need to have a high ceiling if you're not going to be up there. It just means you have to work harder to heat and cool the structure. So I designed it with efficiency in mind. I decided to use 2x6 for the framing because it's easier to work with, it takes more and bigger fasteners, and it's also going to give you more room for insulation, radiant barrier, and other treatments. I also like how 2x6 walls stand up by themselves a lot easier than 2x4 walls, and since I'm framing it all out alone, anything that'll give me the edge and increase safety is a good idea. In normal framing, the board that's on the bottom of the framed wall is called a sill plate. It's just a piece of 2x6 or 2x4 that's laid down flat, and you have your studs or verticals coming up off of that. In my building, the floor is simply a concrete pad. Concrete is porous and by nature will wick up moisture, and this moisture can end up trapped underneath the sill plate, and it can actually rot out the sill plate. Of course, it depends on how much moisture you're talking about. It's better to just go ahead and protect the sill plate from moisture and assume there will be moisture and don't take any chances. Once you build the structure, if there is a moisture problem, you can't really do anything about it, and the sill plate could potentially be rotted out, and that would be a disaster. In construction, I've learned it's better to just go ahead and spend the extra day working the details and adding a little more protection and a little more thought. It's hard to do that when you're tired and you've been working and working to make that extra effort, but I tell you, it will increase the property value and it will pay you back in the long run. And when you sell the property, you'll be able to point out that, hey, I did all these extra details here, and this is a well and solid built structure. It will pay you back. I wasn't sure how I wanted to protect the sill plate from moisture, but I did seal the concrete, and I knew I had to do that at the very least. I also use various underlayments underneath the sill plate. You could use tar paper. There's different underlayments you can purchase that are intended for that use. I also tried experimenting with extremely high quality tape. It's a type of tape that sticks extremely well, and it's very tough, and it's absolutely waterproof. I don't really care what it is. I just need to have something underneath the sill plate that blocks moisture, and there probably never really will be a lot of moisture, but it's insurance in case there's a problem. You don't want to lose the whole building because of one detail that costs $10 to put underneath. Here you can see the treatment that I applied to the concrete. I have not done the entire floor. This is a made in USA concrete sealer, and that goes down first. So the sill plates are not on bare concrete. You should never put sill plates on bare concrete. It's better to put something in between to protect the wood. Although this is a building that's going to be conditioned and dry, it's just not a good idea to put down bare wood on the concrete. On top of the sealed concrete is an underlayment. This is a very high quality tape. It really doesn't matter. You can use tar paper, just whatever you have, but the more you put between the concrete and the wood, the better, just to give you a little insurance and make sure the wood is protected. And here's a view of the caulking, which I did. The footers of the metal building are steel tubes. They're square tubes, and I believe they're called footers. And all the way around I took caulk and I ran caulk all the way around to prevent moisture from coming in and getting underneath the sill plate where the wall is touching the footer. Now over to the right is the roll-up door, and this is a potential area where moisture could come in. Let's say you have a hurricane or a storm, or you leave the door up and forget it. So this area is going to receive additional treatment for moisture to protect the building, the cabin, as I call it, and to prevent moisture from working its way over to where the sill plate is. Right now, I just have the concrete sealer and the barrier or the membrane or underlayment, and that would be good enough for now. To begin construction, it's important to carefully mark and measure your layout on the concrete floor before proceeding. You could use a marker to do that. That's what I did. Could also use a chalk line. You could use tape. You could scribe a mark in the concrete, or any number of things. It's important to do this because as you begin construction, it's easy to lose track of where everything goes, and mistakes are punished. So if you make a mistake and you built several pieces of a wall and you realize you're 6 inches off or you're out of square, it can be very, very annoying to correct those things. So the foundation should be very, very carefully measured and marked, and try to keep checking it once in a while, make sure it's in square, make sure the walls are vertical, and so forth. The more attention you pay to these details earlier on in the construction, the better the final results will be, and hopefully there will be less aggravation and less mistakes to undo later. I went all the way around with a marker and marked the concrete where the walls go. I measured extremely carefully, and the concrete has these helpful lines here. Nice reference mark in the concrete, and I can use that for doing all my measuring and all my squaring and so forth. So I know where these walls go, and if they get a little kicked out of position, that's all right. I'll kick them right back. To frame out a wall section, I simply took two 8-foot boards, laid them on the concrete. I then attached the verticals, which are 24 inches on center, and these are trimmed to about 7 feet. And I square them up. I line them all up. I measure and mark the layout on each 8-foot board using a tape measure and a marker. So you want to make a mark every 24 inches. So it'll double 24, 48, and so forth. And just keep going all the way down to the end to mark all of the stud locations. You do that on both sides, and then you put the studs in between, and then you make sure it's square, and you put in the fasteners, which could be nails or screws or anything you want to use. Boards from the store are always going to be warped and twisted, and lately they seem to be worse than ever. Some of the boards are so radically warped and twisted they are incredibly difficult, and so the use of heavy-duty clamps to force the wood straight and temporarily twist it into shape while you put in nails or screws. It's almost guaranteed if you want straight walls, you're going to have to deal with some warped wood, and you're going to have to figure out a way to twist it into shape and nail it into place. The walls can then be stood upright and slid into position. In my case, I was alone, so I used a rolly cart or a dolly to help move the walls around. They're quite heavy, especially 2x6, so if you're alone, you should hopefully get some help. It's nice to have help when you lift the walls, and it's also nice to have help when putting them into place. I started by framing the walls that were against the walls of the metal building. This increased my confidence early on in the project because it gives me a place to push the wall up against, and I don't have to worry as much about it lining it up. And it also helps hold the wall upright. Once the wall is upright and firmly set into place, you can check the wall with a level and make sure that it's not crooked or leaning. In many cases, the wall will have to be forced into square because it may be leaning. Also, the boards can be warped or crooked, so they may not sit flush up against the wall. In many cases, there's going to be some gaps somewhere. It isn't going to be perfect. The wood is not perfect. The steel is going to be fairly straight, depending on how it's installed. So you may have to accept minor gaps and tolerances. However, you should make sure the wall is vertical because that way it will carry the load down into the concrete more effectively. If the wall is crooked or leaning, this is rather dangerous because if there's a load placed on the wall, it could collapse. Generally, in framing, you want the load to go straight down, straight vertical down into the concrete or foundation. Anything that's slanted or crooked or not supported by a vertical stud is going to misdirect the load, and it could cause a collapse of the wall or the structure. And you should never depend on the shear of fasteners to carry a load. So make sure that if you were to take the fasteners out, the wood would remain stacked. That's one way to look at it. If you take the fasteners out, that's assuming that the wood wasn't moving around and didn't fall over. It would stay where it was. If it falls down when you take the fastener out, that means the shear of the fastener or a sideways force on the fastener was carrying the load. The 2x6 walls, after being framed in, are anchored to the metal posts of the building These are the kind of L brackets intended for metal buildings and are often used to construct metal buildings, so they're absolutely strong enough to handle what I'm using them for. At the top of my walls, I join them all together with another 2x6. This is called a double top plate. A double top plate really locks the structure together at the top. It makes it much stronger, and when the beams or joists come down on that top plate, they are much more able to carry the load and resist any deformation. Not that I'm going to have that much weight up there, but it makes me feel better to see all of that extra material up there holding all the structure together and making it extremely strong. It is on top of this double top plate that the beams or joists will rest. I am using beams to hold up the ceiling of my cabin. You could also call them joists. Due to the width of the structure, which is 14 feet, the joists or beams will be spanning a little over 13 feet. There are all sorts of ways to span such a distance using common lumber, but of course some ways can be dangerous and may not be up to code and yada yada yada. In my case, I'm doing a two-phase plan. I'm going to create beams which are glued together and attached with structural screws. The beams consist of 2x6x8 lumber, which is overlapped in the middle to create a span of approximately 14 feet. The actual unsupported area is going to be less than 14 feet. Then I fill in the missing areas with additional 2x6. Normally, in a beam that does not receive further treatment, as these will, you would have a layer of plywood in between. You can see I don't have any, and that's because I don't need it. These beams are going to be finished in place, and then the blocking will be installed. Right now, all I need to do is hold up plywood and insulation. They're not really going to bear any serious weight. All of the pieces are attached together with liquid nails and large structural fasteners. Normally in a beam, it's called a glulam beam, I believe is one of the names. You would have a strip of plywood in the middle, which is also glued and attached with screws. But I am departing from this normal route. The beams are going to simply support the ceiling and the insulation for now. They're not going to carry any great weight. Using this method will allow me to get the ceiling up, get the insulation installed, and then I can finish the rest of the construction details as I see fit. The beams will receive additional reinforcement and completion at a later time. Until that's done, I cannot really put any serious weight on them other than the 1/2-inch plywood and the foam board insulation. I can walk on the structure to some degree, but I'm very careful and I don't want to have any problems. So I want to make it clear that these beams are not structurally sound according to code. Normally in a house or normal construction, beams would not be constructed this way, so this is just a specific custom way of making beams for my purpose, and normally you don't finish beams in the air. That's just not done. This is just the solution that works for me. At either end of the building, I finished it with 23-inch long, I guess, rafters. Very small. And I kind of like the way it looks, but those are going to be covered up. The door will be framed into this opening. Currently there is no bottom plate and the door has not been constructed. So that's been left open on purpose until I decide exactly how to treat the door opening. On the back of the cabin to the left, there's a large opening which has been framed in. This is intended to be used for future expansion. Right now it will be closed off with plywood. In the future, the screws can be removed and the building expanded. That's a 2x4 beam, two 2x4s sandwiched together with glue underneath a double top plate. Later, this beam may require additional reinforcement, but it's enough to get the structure up and get the insulation installed. Right now I'm sheeting in the roof deck, or the ceiling, or whatever you want to call it. In actuality, this is going to become an enormous storage area after the beams are completed and all the construction has been done. An enormous amount of space will be available, over 250 square feet, to store anything I want to store. The roof consists of 1/2-inch plywood. I was not willing to pay for 3/4-inch plywood. So I ran up my Lowe's card and just got the 1/2-inch. Later on I will come in and sheet over it with 3/8-inch just to make the floor extra strong. So I'm not worried about it right now. There will be no heavy weights up here. I might throw a few cardboard boxes on top just to get them out of my way. Now here's an update on the roof. I've sheeted in most of it. I'm pretty tired. Plywood is pretty heavy. It's turned out pretty good. 1/2-inch plywood is not really strong enough to walk on, so I have to be really careful. Later this will be probably sheeted over with 3/8-inch overlapping, just to make it really strong. And here's a view from underneath the roof deck. The only part that hasn't been done is from right about here. There's a strip, a narrow strip that hasn't been done, and I'm not going to do that right now. Probably tomorrow. The plywood coming from the stores these days is extremely low quality, so I'm having to use deck screws that are longer. I'm using 2.5-inch. I have some older sheets. That's this one right here. That's an older sheet, and that plywood is higher quality. It's very flat. It's almost perfectly flat, and it's very easy to install, comparatively speaking. It's barely warped at all. It doesn't have a bunch of pieces missing. The newer plywood that's more recent is just terrible. It's falling apart. It has pieces missing. It's extremely low quality, and the price is much higher. So okay, the entire roof has been sheeted in with 1/2-inch plywood, but that's only part of the story. The roof of the cabin is going to deviate from norms. It's going to be a foam sandwich. On top of the 1/2-inch plywood, I'm going to be laying down 2-inch thick green foam board insulation. On top of that is going to go 3/8-inch plywood to protect the foam board from wear and tear. Now there's only going to be storage up here. It's not going to be a live load. There won't be people running around all the time. Just some boxes and just different odds and ends. Over here I'm notching out the foam board insulation using my Ryobi multi-tool so that it will fit around these braces, which are every 4 feet on this side. And there's the first piece with the opening cut for the braces. Thankfully, there's only 2 more of these to do. There's 4 total, and the rest is just normal work. Alright, there's the progress so far. So that's R10 plus the wood. And I don't know what the actual R value is. This is much faster than cutting individual pieces to go in between the beams. I actually like how the beams look, and I don't want to stuff a bunch of green foam board up in between. I got done doing that recently already with the ceiling, and I'm not interested in doing it all over again and covering up the beams that I made, which I think look really nice. So this is a continuous insulation barrier. I'll probably spray foam the gaps. There are little gaps in between. These boards are not perfectly shaped, and of course neither is this cabin. So I will have to go in later and put a little spray foam, not very much. There's just minor gaps that have opened up, and I'll probably tape and seal some of the edges. Now, of course, foam board is a moisture barrier or retardant, so I will have to be careful not to let the humidity come up in here in this space. Once it's all sealed off, I don't want to have excessive humidity up here. And this is going to be tricky because it's multiple insulated envelopes that I'm creating here. This is tricky. This is not how a structure is normally built. So I am deviating from the norm here, but I'm doing it for a reason, and it'll all work out in the end. And here's a quick clip of the first wallboard that has been put up. It's a 4x8 sheet of 3/8-inch plywood. Here's the view from the outside. Had to trim a few inches off the top. It's just shy of 8 feet. Building imperfections. So despite all my best efforts, the structure is not quite square. So that means the plywood, which is relatively square, does not fit the way I'd like it to. But I'm going to have trim, so it's really not a big deal. It is a little aggravating. But if I hadn't made all the efforts, my guess is this structure would look like a triangle. It'd be really out of square. For the screws, I'm using the deck screws. These are expensive screws, but I don't want to have any problems later on down the road, so I spent extra money and got nice screws. These are the 1 5/8 inch. They're a little on the short side. The plywood I'm using, it's 3/8 inch. It's much better quality than some of the other plywood I've seen, and these screws are just barely enough. They could be a little longer, but they're just barely enough, and I have a whole box and I want to use them. Just to be safe, I'm also using longer deck screws. These are really good. They pull down really good. They have good pull. They bite into the wood. And they countersink themselves because of those little ridges they have. You can see the ridges going around the head of the screw. Those are to sort of help countersink into the wood. I did purchase some countersinking bits. I've never had any before, and I probably will try them out. But these screws are doing the job, and by mixing the longer ones with the shorter ones, I'm ensuring the board doesn't go anywhere. I don't want to have any problems, so 4 to 5 of these in one board is just a little bit of insurance, that's all. Also, a good deal of the structure's strength comes from, believe it or not, the plywood sheathing. And even though this is only 3/8 of an inch, it's really thin. It adds a tremendous amount of lateral stability to the building. So having good strong screws in there is going to ensure I get that extra strength from the sheathing. To put in some of the screws, I'm using my Ryobi Quiet Strike impact driver. I only recently got into using Ryobi tools, and this one was a little more expensive, but sure enough, I don't have to wear my hearing protection like I used to. It's actually very quiet. The only time I heard it make a lot of noise is when I was trying to drive a structural screw, and right at the end it made quite a lot of noise. I now have all of the external plywood sheathing on, so the entire room is closed in now. And I have a sheet over the door area, which I'm working on framing out now. Over here is the area where the future expansion will take place. It's been temporarily closed off with plywood, and I put a stud right in the middle. And eventually that's going to be opened back up, and another room will be built onto that area there. And there's the rough opening for the doorway that has been framed in. It's just 3 pieces of 2x6. And I've got structural screws on the side to tie it all together. There's the other side. There's the bottom. So eventually my door will rest here in this opening. And here's the current state of the storage area, or roof, or floor, or however you want to look at it. Plywood has been placed over the majority of the roof. It's solid as a rock. I can walk all over this, and it's not a problem. It's very, very strong, very rigid. Over to the left, there is a pile of stuff I've been storing. I have a lot of foam board insulation, just random stuff that I need to store and keep out of my way. And it's been working great for storing small items. I am taking a break from the construction right now, so I have not completely covered the floor. Shouldn't be a big deal. I have different ideas about how I'm going to finish the floor, but right now I have plenty of storage and I'm not worried about it. One more construction detail I added to the cabin. There is this 2x6 crown or lip going all the way around the outside top edge of the building. The first reason for adding it is this roof consists of a foam sandwich, and if the edges of the foam are not supported, they could be crushed anytime somebody tries to put something up there, maybe a long 4x4 they throw up there and slide it up and let it go down. The foam would be crushed and damaged over time. So this crown or lip at the top protects the edges and supports the plywood. There will be additional wood underneath, obviously, because the foam is thicker than a 2x6. So the additional wood will be there to support the plywood and carry the load down to the 2x6. The second reason is that if I choose to insulate the outside portion of the wall, it's going to make it a lot easier if I have a nice lip to put the green foam board up against. And I'll show you here what that looks like. And here's what it looks like. You see the foam board sits right up underneath that lip. And the foam board does vary in thickness. It can be 2 inches plus or minus, but it more or less will fit right under that lip and will fit snugly. I could also spray foam that gap before I put this foam board in. If I need to, I can attach more plywood and hang it from this edge here straight down over the foam board. And having this lip here is going to be a tremendous help in getting that in place. Of course, I would also need to attach blocking lower down. It's not as simple as that, but it will help. One more item of interest. It's been quite beneficial to have an outer insulated envelope on this building. It stays warmer in here than it is outside. Of course, in the cabin, it's even warmer. Any waste heat that the cabin gives off is used a second time to heat the outer part of the building. Initially, I was very disappointed when I put all this green foam board in. I thought it was going to be toasty warm in here, but the reality is it's just too big of a building to expect one little propane heater to heat the entire building. That is just an unreasonable expectation. One of the major heat losses is the roll-up door. I did play around with some insulation, but I lost interest in this project for the moment. I wanted to focus on building the cabin instead, and that turned out really well. I do have a plan for insulating and sealing off this roll-up door extremely well. It's going to cost a little bit of money, and it's going to take some time. I will probably record some videos of that work when it happens. Right now, the urgency is gone because the cabin keeps me warm. The outer envelope of the building is still warmer than it is outside, and I can still bring my propane heater in here to the outer part of the building if I wanted to. I haven't felt the need to do that yet, but it's certainly an option. So one of the things I looked forward to when I was building this cabin was getting more organized and getting these piles of junk sort of put away. So yesterday I did a big cleanup and I got everything organized and stored neatly. I moved my workbench over here. I built this recently. It's a saw cart or workbench. And I cleared out this entire corner. This entire corner was full of stuff. Down here you can see I've done a lot of work organizing and cleaning up. And all my foam scraps are up in the overhead area. I moved all my lumber over there. And now I have somewhere I can keep things like this out of my way. And that's why this area is so useful. It's just wide enough to be useful. You don't sacrifice too much. And there's the cabin wall. This is the 20-foot long wall of the cabin underneath all this stuff. That light that you see up there is powered directly off of solar panels. There's no electronics, no battery, no charge controller. When it's daylight outside, that light comes on and it lights up this whole area. For 3 days I've been testing the thermal performance of this cabin, and I was surprised to discover that it's very easy to keep warm, and I burned almost no propane in the last 3 days. Even with a sheet over the door, it's very easy to keep this building warm, and that was not the case at all before. I could burn propane for hours and hours and hours, and it was very hard to get even a reasonable temperature. This morning I did not turn on the heat at all overnight. When I came in, it was 17 degrees or 18 degrees warmer in here than it was outside. Of course, the metal building itself was cooler than outside, but you expect that. There is a continuous cold draft coming in where the door should be. And at the top of the cabin there's gaps where the plywood is, so there's a warm air current rising up. But even with all these things taken into account, it's very, very easy to warm this cabin and keep it warm. I did some cleaning up and organization, and I'd say the size I picked is good enough. I'm not disappointed in the amount of floor space that's available. I should be able to get one more workbench in here and still have plenty of storage. I did put up one shelf over there in the back. So in order to keep this video from getting incredibly long, I'm just going to make this the end of it. I will be posting additional updates and videos as I build out the rest of this cabin. Obviously it's not finished, and I don't know when it'll be finished. But I will be adding additional finish work, and I'll probably put down some flooring. I have not yet insulated the walls over there on the left. You can see these walls here. Those aren't insulated. The other two walls are, because they're the walls of the metal building. And yet, even with that taken into account, it's very easy to keep this cabin warm. And it holds its heat well overnight, which is amazing. Wood does have some R value, and those studs do have some R value. I also have some things propped up against the outside of the wall towards the back end. Over in this area here, there's things, foam insulation propped up against the wall, and I'm sure that's helping some. I'm going to take a break from construction since I've been doing that for months, and I do include the green foam board insulation install that was done in the metal building. That was a ton of work. But I will be able to do smaller things and projects and electronics work inside this cabin, which I'm very eager to do. So I will be posting updates and videos on that as soon as I can. A few quick hints about what I'm working on as far as projects. I want to do some lighting out here, and I want to build one additional workbench. So there's going to be some electronics videos, solar related, of course. And I believe I will be adding, hopefully very soon, a battery bank, probably lithium ion, out here just to power this cabin. Of course, I'd be able to use it for other purposes as well, but its primary purpose would be to power this cabin. I do plan to finish the interior of this cabin, but that's a long shot right now. Certainly I'll make videos about it when I do it. I really would like a nice floor in here. I do like concrete. There's something about concrete. It's just really tough, and you don't have to worry about anything. But it'd be nice to finish the floor. The beams are going to stay uncovered. I really like the way those look. I just can't cover those up. I just can't bring myself to cram green foam board insulation in between each one of them. I just can't do it. So that is a reason why I insulated the roof using the method that I did. I made a foam sandwich out of 2 pieces of plywood and foam in the middle, and that seems to be working out extremely well. Okay, thanks for watching this video. I hope you enjoyed it, and I hope it helped someone. See you later.